Hi there and welcome to the Audiophile. I wanted to talk about connectors and cover some of the basic ground rules about connectors when if you're building your own cable or if you're looking for a cable and the connector part of the question is really important to you. What should you be looking for? What sort of things are really important? So it brings us to a few different connectors. FuTech is one of the connectors that we use on virtual dynamics cables. And we use this particular unit because it's made out of a copper alloy. And the copper alloy, that's a female end, so we can't see the actual contact. So I'm going to open this guy up. The copper alloy that you can see through there is a very conductive material for being able to build a connector out of. So when we open it up and we take off the sheathing on the inside, you can see that once we get that little fella off, that we've got nice, shiny, brand new looking copper sitting underneath. One of the things immediately you can see though is that it's starting to tarnish. Now, once you put your fingerprints on it a few times and you start to get some new debris in there, you'll find that it'll start to tarnish very, very quickly. Now, the reason why I say that this is a copper alloy is because we know that if it was just a straight pure copper, it would already be oxidized even if it hadn't been touched, to the point where it would be quite a bit more dramatically discolored than this. Now I'm going to take you over to a back of an amplifier that recently I put some pure copper connectors on. So if we come on over here, you can see that these copper connectors were installed only a couple of months ago. And they were a pure copper connector. And you can see the dark brown color that they have now because they've started to oxidize quite badly. So that's what happens to copper over a period of time. Now this oxidized material does not conduct electricity. So of course, as it builds up and gets thicker and thicker, this is going to become a much worse contact. So these, if you're going to use a pure copper conductor, they have to be cleaned on a regular basis. Now, the other alternative for a good, high-quality conductor, as far as the quality of the conductive material is concerned, there's only really two choices. All of the rest of the choices have much lower conductivity ratings. There's copper and there's silver. Now, everything that is silver, that looks silver, I should say, is not necessarily silver. This is plated with either nickel or rhodium. Now, as a manufacturer, it's difficult for us to tell for sure whether this is actually plated with nickel or rhodium or another type of material, because of course we weren't there when the actual plating process is done. So if we're shopping around and we're looking for these conductors, of course in this industry, like every other industry, not always are the products exactly what you thought they were supposed to be. For example, a little while ago, I was told by a sales rep that this particular binding post was made out of pure copper and that it was gold-plated. But if we were to go at it and actually take a look on the inside and see what this guy is made of, you can see that it's not copper at all. In fact, it's just brass. Now, brass has only about the 30% of the conductivity of copper. So that if I was going out of my way to say that this was built and was a solid or pure copper conductor, that would be a pretty gross mistake to make, because this conductivity and this conductivity, copper and brass, is pretty dramatically far from each other. There's just not the same sort of conductivity whatsoever. Again, about 30% of the conductivity in copper or in brass that there is in the copper material. So one of the things that we like to do is we like to rip things open and find out what they're made of on the Audiophile. This is one of a couple of the connectors that we've been using on our cables. Now both of these happen to be pure copper. Now I'm going to just show you why I say that. Of course, this guy here, when we bring him down, you can see the copper underneath. So as we take away the top material, we can see the copper below it. The problem is, in this particular conductor, is that when these get exposed, they start to oxidize, and copper itself, once it becomes oxidized, is not a very great, doesn't have a conductivity. It starts to lose its conductivity. When you flip it over to the other side and see the material that's on it, of course it stays nice and shiny and new, it's easier to clean, but it's not nearly as conductive as the copper is below it. So there's going to be this point of resistance, and that's something that we'd like to get away from. Now, if by chance you're looking at this and you're trying to make a purchasing decision based on connectors alone, don't do that. If you're building a cable, do it yourself and you want to buy a good connector, go ahead and do that, but be careful because you can spend an awful lot of money and find something that doesn't make a whole lot of difference. For example, receptacles. Now this is our Hubble receptacle, and we've talked about the fact that we think that brass is not all that horribly conductive. But looking at it, it's obviously made of brass. So why would we choose it here at Virtual Dynamics? Well, the reason why we choose it is because Hubble, which is an awful large corporation, claims that its brass is within a couple of percentage points of the conductivity of copper. Now that makes this brass very, very unique. So not all brass is the same. Now I've never seen another manufacturer ever advertise something like that. So this is very, very unique to Hubble as far as the claim is concerned. For the most part, people agree that brass is very low conductivity in comparison to the coppers that we should be using. The important part about this particular connector, though, is that when you plug something into it, see, when copper bends, or even when brass bends, it bends pretty easy. It's pretty soft material. This is obviously, again, an alloy, and one of the things that we've noticed about the Hubble receptacles is that when you plug in, there's a good, tight electrical fit inside that keeps that cable locked into place. If you were to change out a receptacle and hear a really big difference between your old receptacle and your new receptacle, chances are, even though this is supposed to be far more conductive than the receptacle in your wall, the biggest thing that you heard is the fact that you went to a brand new, clean receptacle. Cleaning your old receptacles and cleaning your RCA outlets, that sort of stuff, cleaning off your speaker spades, can make a tremendous difference in the clarity of an audio system. So make sure that that's something that you maintain on a regular basis. Of course, if you're using Quicksilver, the product that we have on our website that allows the oxidization to be removed from the surface, you're going to find that oxidization really doesn't happen, so you don't have to clean nearly as often, in fact, maybe not even at all. Now, as we go to look at a cable like this is an audio cable that was brought out by a company. They had selected a standard brass receptacle. What we're looking at here is a fairly common or relatively inexpensive connector. I don't know what this cable sells for, and it really doesn't matter all that horrible much. What we're assuming, just looking at this, is that the technology for this cable must be inside the cable. It must be somehow based in the wire itself. So the connector, when we're talking about speaker cables, what we've done is we've taken a solid copper spade and we've milled it down, and it's gold plated directly over top of copper. Now what's going to happen in this particular case is that the copper has got the gold instead of something like rhodium or nickel over top of it. And that's much more conductive. So it's going to make for something that doesn't oxidize very quickly at all, but still has the great or better conductivity. So if you can make a solid gold one, that wouldn't be bad either. But a gold-plated copper is not a bad idea. I want to show you this, though. It's important when we're looking at conductors and connectors while we're on the subject. What is a conductor supposed to do when you mount it to the back of something like this amplifier here? Now, as we go to install our spades, I want you to pay special attention as to how that spade actually fits as we're putting it in, because the mechanical fit of the spade becomes critical on making a really good joint. So we're going to take one of the older ones that we used to use and put it in there and lock it up. And you can see that as I jiggle it, it plays quite a bit. There's a lot of play inside here. You can notice that one side is actually thicker than the other, so it wants to move a little bit more on the right-hand side than it does on the left. Now, if it happens to be that the spade on the side